Good morning. Hi, everyone. My name is Jessica Mong. I am an engineering manager at SurveyMonkey on the machine learning engineering team. And so I'm curious, how many of us have taken have created a SurveyMonkey survey before? Nice, awesome. How many of us have taken a SurveyMonkey survey before? As I expect, cool. So as many of you may or may not know, we're actually a 20-year-old company, and we have about 17.5 active users. And we collect over 20 million answers to questions every single day. And so this actually gives us a prime environment and a lot of data also to be able to apply machine learning at SurveyMonkey. So I'm sure some of you are curious to know what we actually use machine learning for at SurveyMonkey. Thank you. So we actually use it, I'd like to think of it in three different ways to delight our customers. In this case, we build tools that make it easy for them to derive insight from the responses that they get. Things like sentiment analysis, and also something we call SurveyMonkey Genius here, where we give insights like the prediction rate, the expected prediction rate, completion rate, or the expected completion time, so that it helps them have insight on how to craft a survey to get optimal responses. We also do things to protect our customer. And in this case, we build models for spam and for phishing. And then finally, we want to support our business operations. So in that sense, these are the three different ways we apply machine learning at SurveyMonkey. So with our use cases growing over time, we created a separate team called ML Engineering at SurveyMonkey in end of 2017 to be able to operationalize, scale, and democratize machine learning at SurveyMonkey. So that's our one focus as a team. That's all we spend our time on every single day. And we're a team of just 8 people. So the agenda for today, really, I'm going to walk you through the journey of machine learning at SurveyMonkey, and especially how we've scaled our platform over time. I'm going to walk you through what we think are the 3 pillars of an effective ML platform. We'll take some questions, and then hopefully we can wrap up. So let's look at the journey so far. When we first started with ML, it was really ad hoc ML requests. So you'd have a data scientist that works in their own environment. So in this case, it could be like Jupyter notebooks. And then once they're done, they export data or insights to PowerPoint and share with, let's say, the product team or the finance team. The next phase we kind of went to was for ML as a service. In this case, the data scientists are still working in their silos. And then once we finish, we wrap it up with an API. So we expose the API to our end user. And I'm curious, actually, how many of us are in this phase right now? OK, cool. So let's look at the flow for our phase 2 when we think about ML as a service. The data scientists do some data exploration. They do some data backfill. Let's say 3 years if they want 3 years of data, worth of data to build a model. Now they do some modeling in their Jupyter notebooks, and once they're done, they hand this off to ML engineer to wrap up with an API, right? And then expose this to our clients. Now once MLE gets this model, we try to replicate the features for real-time serving. So if we had 75 features that were created for training, we try to replicate them in real time. Now, I don't even have to say much to know that that's problem-prone, but we'll dive in a bit deeper later on. And then finally, we deploy the model service. And when we're looking to refactor and redesign our ML platform, we noticed that there were a lot of pain points, basically. And we had to talk to our stakeholders, ML engineering, to our clients, which are other internal services, to the data science team, and really tease out what those issues were. And boy, there are a lot of issues, right? For our stakeholders, for data scientists specifically, data exploration was too slow, and the data backfill process was also very slow. You also ended up with a lot of duplicate features, like num-email sent and email sent, because data scientists had no way of knowing what features already existed or were being used by previous models, and so they just went ahead and created those features all over again. We had no sandbox for our data scientists to kind of explore and test their models once they finished building and modeling, exposing it to some form of traffic, even if it's in a testing environment. A lot of friction between ML engineers and data scientists, especially as we try to replicate those features in production. So you can imagine that finding out the number of responses a user has gotten over the past 3 years might be easy to get during training time. It's very hard to get it during prediction time. So because of that, there's a lot of computation of features in real time, which really led to a lot of slow APIs. And because we really can't replicate successfully, we ended up with feature mismatches. And finally, we just had too many services. I'll dive in a bit deeper into architecture later on. But when we have a client and we give them a model service to consume, it makes things easy to get off going. But what happens when that same client wants to consume 5 different models? It means that they have to interface with 5 different clients, different services, which they consider to be just one service, right? Because they're saying this is an ML service, in essence. And so that really brought us to thinking of ML as a platform. We realized that thinking of ML platform just from a perspective of serving, while it solved some issues and got you running, it didn't capture the full picture. And so we thought about ML not just from serving, but also from a model management perspective. What happens when you start to serve not just 5 models, but 12 models? And what happens when you have to serve those 12 models in EU with GDPR right now, right? Like you can't export data from the EU back to the US. What happens then? And then the last pillar, and I think is one of the most essential, and it's going to be really hard to delve deeply into, is data. So we're going to be doing more talks to talk about the things we've done on data. So right now, today, I'll focus really on serving and model management. And if I do have time, I'll fit in some stuff from data, and then we'll take questions. So let's dive into serving. So here's what our architecture looked like in 2017 when we took over the team. We had a client, and we had a model service. We exposed our model service to the client using an SDK, using Nginx for routing also. Now, once the model service receives a request, it would fetch some features from the database. We have another model, model 2. We expose it to client 2. And then once the model receives a request, it would probably try to fetch data from the DB or from API, so it could combine data from these 2 sources. And then model for client N, right? Same thing over and over again. We expose these models to them. And then we could have a client that talks to multiple models. Let's dive into what the flow actually looks like in our model service. So let's see what our old prediction flow was. We get a request. A model service gets a request from the client. We have to validate the input. Once we validate the input, we fetch features. Now, as I mentioned before, this was the most time-consuming and problematic part of the whole flow because you had to compute features, potentially real time. We did a lot of optimizations here, for example, on the database, pre-computing features, but we realized that it's not going to cut it for the next few years. And so that's why we had to have data as a separate pillar and do work there separately. Next, we transformed the features. So this could be things like applying some one-handed coding transformation. And then finally, we compute a prediction and send the result back to the user. Now, while this was good, in the sense that it supported all our ML serving in 2017, we had over 5 models then. It helped us separate resources because we could deploy a model to its own nodes. And we also supported multiple DS libraries, actually, because we provided a common interface for all our different models. So in that sense, I could, for our service, we used a plugin architecture. So I could deploy it to one node, and it's running, let's say, the spam model. And I deploy it to another node, and it's deploying the sentiment analysis model. However, there were a lot of bad things with this system. First is that we only offered synchronous serving. That means if you made a request to us, you had to wait to get a result. Now, this didn't work for all flows. We had multiple SDK clients, like I mentioned before, where if a client was integrating with 5 different models, they had to have ML service client 1, ML service client 2, and 3, and 4, and 5. And then we had no A/B or shadow testing functionality built into our system, which meant that if we wanted to roll out a new model of the spam, a new version of the spam model, for example, we had to get our clients to actually integrate with the second model and send traffic to us in the background. And finally, we had no feature sharing opportunities. Sometimes a lot of the features that we're extracting were actually similar across the different models that we're serving at the same time. And so if 2 requests came in for 2 similar features at the exact same time, we computed those separately. It's a waste of resources. So we realized very quickly that we needed a new layer, kind of like a gateway. Now, this gateway will provide a single point of entry for our users, and it would have routing functionalities that would help us implement things like A/B testing or shadow testing. We would have standardized logs, standardized metrics, standardized monitoring for our applications because they're coming through that single layer. And then finally, it will help us really scale and have the ability to also scale as we increase traffic to our different models. And so we came to an essential point in that journey where I think every software team comes to it. Should we build this ourselves, or should we buy it in some way? Either a tool that we have to pay for, or a third-party tool that we can get for free. And so in exploring the buy option, we kind of looked to pure gateways like AWS Gateway and Kong. We did POCs to see if we can kind of integrate it with our system. We also explored purely ML tools like Clipper and Hydro serving and TensorFlow serving, and did proof of concepts with these toolings. And while we decided to build in the end, because for a number of reasons, some of these tools were really, really early when we were doing this exploration, so it was not mature enough to be adopted in production. And then the POCs actually helped a lot, because for some things, we were able to uncover some complexities with integrating them in our own system with our own infrastructure. And so while we decided to build, we took away a lot of learnings about features and characteristics of these systems that we could actually replicate on our end and extend our system. And so here's what we look like today. We built a new gateway that is the one point of entry for all our clients. And we did something very essential. We took our feature extraction from the model services to the gateway level. And so once we extract the features, then we make the calls to the model services if we're able to actually successfully extract these features to get the prediction for our clients. And then with our async functionalities that we've provided to our users, we were able to build some integrations with the message bus. So once we get a result, we can publish it to the message bus and have our clients consume them. Now, what the message bus and async mode has allowed us to do is go a step further to have more of an event-driven process, where we can actually subscribe to events and track the users as they go through the application. And then once we do that, we know what critical points we have to trigger a prediction. So we're not waiting for a client to call us. Now let's dive into what the flow looks like right now. And I've put the old flow kind of for comparison. So in the new flow now, we have 2 layers, the ML service gateway layer and the model service. As I showed in the previous architecture slides, we actually use pyramid applications, the framework, to build our applications at SurveyMonkey. And we use G-Unicorn workers when we deploy them. So for the ML service gateway and the model service gateway, we took an audit of all those steps that we took when we actually serving a prediction. And we realized that the feature sharing and the gateway functionality had something very similar in common. They were making requests out and waiting for a response. And so we're able to optimize that layer with asynchronous G-Unicorn workers to help us speed up the application. And for the model service, we realized that it's doing a lot of computation. And so we left it with synchronous workers there. So once we validate an input, we resolve the model. This here determines which model it should go to. It takes into consideration things like A/B testing, shadow testing. Should I send this to another model in the background, transparent to our end user? Finally, in the gateway, we fetch or share the features. We introduced a caching layer here to help us share features or fetch them if we need to from the database and our APIs. Once we have the features, then we call the model service. The model service does its user transformation and computes the prediction. And once we're all done with this, then we share it whichever way we've agreed on with our clients. It could be through the message bus. It could be in a database for fetching later on. Or it could be synchronous if that still works for our clients, our end clients. So we've seen a lot of benefits with our new prediction flow. One is that with our optimizations, we actually have better response times. With our test, our initial model that we released, we saw a saving of 126 milliseconds on average. We're able to reduce resource usage because of those optimizations that we made in each layer. So for our model services, we went from 8 nodes to 2 nodes. We have flexible and faster integration patterns. For some of our models, it took upwards of 2 months to be able to deliver a full integration because our clients had to do so much work on their end to account for our synchronous serving. Now that we have asynchronous serving and event-driven predictions, we're able to offer better integration patterns to our clients and have them move quicker. And the last is really our event-driven predictions. Since we released this in early Q2, we've had over 4 new and existing models transition to this mode of prediction serving. So a natural progression from serving is model management. What happens when you start serving 12, 20 models in production? And what happens when you have to replicate these in different data centers? So we operate on a hybrid cloud, and I'm curious how many of us are in that scenario where you're kind of transitioning to the cloud, the public cloud, but you also have your on-prem boxes. Okay. So we have a lot of operational challenges with a hybrid cloud. The first, which is not really written on here, but it's really that tug of war. Should we put resources towards moving us to the cloud, or should we just build our stuff here right now on our on-prem boxes? And so the challenges we faced in addition to that were that we had no standards really across all our model management. If I managed one model, it would be a totally different way managing model B. Everything is extremely manual for us. We have complex deployments, and then when you couple that with manual work, just leaves room for error. We had no visibility of model artifacts, which meant that sometimes model artifacts were stored differently depending on the model. And then finally, it was really difficult to extend our infra in multiple environments. Like I mentioned before, we did some POCs with some of these tools that would have been really great to use, but it was really hard to extend our infrastructure with those tools. And so what we've done so far is that we've done a lot of standardization work. As mentioned in the keynote addresses, standardization is really, really key for getting to efficient model management at your companies. So the first thing we did was standardize packaging. Now with packaging, what we get is the common interface for all our different models. And we're able to actually convert all our IPython notebooks to regular Python packages that we could use across the company. We also did some standardization on monitoring and metrics. On storage, we added util functions and moved all model storage to S3. Now with those util functions that we made available to our engineers, we're also able to standardize naming conventions for our model artifacts. And finally, we're able to build tests, standardized tests for all our models, whether it's load tests or functional tests for those different models. That way, it's easy to adopt a new model. And the future is really automation. You don't want to be in a position where you're having to babysit your models, as was mentioned in the keynote. And so a key part of that is really to migrate. Like I mentioned, that tug of war, we're at the point where it makes more sense to put our efforts towards migration. And then once we get there, we can take advantage of tooling that's already available to build all these different features. The first is an admin console, where users can go and at the click of a button, deploy a new model, or train a new model, or discover features. The next is CI/CD features, anomaly detection, and really a playground where people can come at SurveyMonkey and play with the different models that we have. Now, I'm really out of time, so I'm going to skip really over data. But the key thing I want to mention here is that data issues are complicated. And this is something we've experienced on a daily basis. And it really does affect every part of the pipeline. It affects model creation, model serving, and model maintenance after retraining. Data is that layer that just affects every different part of the flow. So for us, we had no standard feature definitions. We had inconsistencies between training and serving, and a lot of dependencies on different data sources. And overall, it's just hard to debug and validate our data sets. So we're fixing different things right now. We've built a feedback loop mechanism that our different models have adopted. An auto-retrain pipeline that's taking advantage of the standardization work we've done. And finally, a central feature store. This is currently in progress, and we hope to be able to share more about this in the future. A central feature store is something that we know in the industry is people are adopting that paradigm in the sense that you have a single source of truth for training data and for prediction data. it does help reduce a lot of the issues that we've seen with data in the pipeline. And so what do we look like today? We're serving over 100 million predictions every single day. And we've seen an increase in efficiency 11 times. And we've been able to reduce our cost to train and deploy a model by 50%. And we've increased our serving capacity to be 20 times what it used to be in the past. So that means that before, it took over 6 months to deploy a really complicated model in production. Now we can do that with all the optimizations we've had so far, even without the best of the solutions yet that are still in progress. And we have these efficiency increases to be able to serve our models in production. So as a key takeaway, you really need to define your unique use cases at your company. We talked about a lot of stakeholder interviews. Talk to the people who use your system to determine what features you need and what you can actually build, and prioritize what you build. Understand your infrastructure limits. We all want to build the best things for those of us who are engineers in the house. But sometimes you're going to have to make trade-offs. So understand what those limits are and build for the scenario that you have right now. Finally, data issues are complicated. You need to pick your battles. It's awesome to build a central feature store. However, if you can do some optimizations on your DB layer while that's in progress, do that. So I don't know that I have time to take questions. But if you do have questions, I'll be outside the room to take any questions. I'm happy to stick around. And if you'd like to stay in touch, here's my email and my LinkedIn profile. Thank you. Oh, awesome. Okay. Hi, guys. We have some time left, so we are getting break. Yeah, no. We are giving our question and answer session for now. Perfect.
All right, we have 5 minutes left for her session, so if you have any questions, you can ask. I'll be around to handing out mics.
Thank you. Well, any questions? Yes, sir.
Excuse me. Oh, sorry. Yeah, I thought.
Thanks for the great talk.
Thank you.
So you mentioned you went through like a POC phase to determine what technologies to use.
Yes.
Was that something that sort of you had complete control over, or was that like, were there other parties involved, like security and network, like IT and like all these
Absolutely.
other partners? And sort of how did you navigate that POC phase when you had multiple stakeholders determining the future of, let's say, an engineering or data science team?
That's a very good question. So for those POCs that we did specifically, no, we took complete control of it. And we did that because we realized that if we let infra, for example, be a dependency, then for better or for worse, we're tied to their timeline, right? And so for things like exploring AWS Gateway, we decided we'll just go ahead and create an account on AWS and test these things out with our own models that we've gotten from some sites, right? We're not using SurveyMonkey data. We're not using SurveyMonkey models. And this helped us move very quickly. I think that if you can isolate yourself and do that work on your own, it's really essential to move in fast. Otherwise, you're going to be stuck in a timeline blocked by infrastructure to give you access to something. And 2 months later down the line, you're like, oh, it's not going to work for us. You could have gotten the answer sooner. So we realized that if we let ourselves have too many stakeholders, we're not going to move as quickly as we wanted. So in that case, we eliminated them as much as we could.
Thank you.
Thank you.
Thanks for the talk.
Yeah, thank you.
Yeah, actually similar question around that. There's a lot of provider as well, so I wonder, we are evaluating SageMaker and all those managed service from public cloud.
Mm-hmm.
And similar thing, we are going through this hybrid cloud phase.
Mm-hmm.
Wonder, have you gone through the same journey, and what are the pros and the cons?
That's a very good, yeah. We've been through exactly the same journey. I think that it's hard to take a 20-year platform and just transition it to like one of these new tools. So I mentioned before that some of them were too early to adopt. That's one thing. Some of them just didn't fit very well with our infrastructure. That's another issue. And then the third part is really, how do we take something we've already built, it's working, what's that investment to actually transition into the cloud, right? So that's all the considerations that we had to take into, that's what we had to take into consideration when we're thinking of moving our whole infrastructure, right? In terms of really the cost effectiveness of it. Yes, we could have taken things, let's say, to SageMaker. But like I mentioned before, being blocked by infrastructure is one thing. We can do a POC, but can we actually move it? And what's the timeline for there? So I'd say it's really just understanding what your constraints are and doing the best work that you can within that. I don't know if that answers your question. It does. And I'm happy. Yeah, it was really just sitting down to say, here are the different tools that we would love to take advantage of. Here are the different tools that are doing innovative things for machine learning specifically. And what's going to stop us from adopting these? And when we went through that, that really helped us expose complexities or issues around integrating with those. And then overall, I'll say, like, even if you do POCs and you do decide not to build, I think it's still a very great experience because you are able to take away so many learnings and patterns. So for example, seeing that all of them had a model management layer for example, for some of the tools that we looked at, informed our decision to build a model management section for our overall architecture. Things like a data store, a data lake, in a sense, like a central feature store, was something that some of these tools were starting to provide, like a central place to gather your features. A/B testing, shadow testing functionalities. Those were all different learnings that we took away from the POC, even though we decided not to adopt. Yeah.
Thank you, Jessica.
Thank you.